So in the previous session, we have plotted or tried to correlate between the rating versus year, or basically explore the distribution of the rating year versus the rating, and distribution of ratings versus uh, various other things. Now it's time to explore more correlations in this fashion. So we try to correlate categories versus rating. So how category is influencing the rating basically. So I have taken the product category and taken unique values from the product category. We have 18 unique product categories. So if I plot review ratings with respect to product category, you could just see household essentials, movies, TV shows, personal care are actually the product categories where the customers are trying to review. We have other product categories where the customers are not even trying to review those products, right? This is what you can just see. So if I have just plotted category on the y-axis and the count as a x-axis and the ratings as individual hue plot in this fashion. So household essential seems to have a rating of 5 at a maximum number, that is more than 20,000. So what if I plot ratings versus the count for individual product category? So if I do that, you could just see uh, the products category such as movies, food, beverages, personal care are the most comes under the rating of 5. So these are all the top reviewed or most well reviewed categories of the products, right? So because since they are coming under a rating scale of 5, so these are all the better rated or well rated product categories. We have also which have crossed the 5 value. So you can just see based on the color, that is clothing, health comes under the highest ratings, but they don't have a count as such as uh, movies, food and beverage. So we can't just rely on these values because they are very less in count. They are around less than 2500, but these values are almost around 15,000 to 17,500. So we can consider these are the top product categories, and which are actually rated well when compared to the other categories which comes under the rating 1 and 2. So now that we have compared ratings versus category, now we can also see the brands versus category. So we have different brand names and ratings as well. You could just see the plot in this way. The Clorox has the highest number of ratings which are actually rated well, because the 5 rating is for uh, around 8,000 plus product for the Clorox. So this is how we try to relate through the or we relate different terms, independency, dependency of each and every term through this exploratory data analysis. So we have another tool called as word cloud, which actually gives a pictorial representation of highest or most frequent words present in the entire data set or a text corpus. So word cloud is one visualization tool which represents the size of the word becoming bigger and bigger based on the frequency of occurrence of each and every word. Suppose if I say, if I just see the word great in the plot distribution over here, frequency distribution over here, great being the most repetitive or most common word. If I plot a word cloud on top of this, the great word would be appearing in a larger fonts when compared to the words such as easy, best, go. So that's what a pictorial representation which assists in identifying the uh, distribution of the words basically based on their frequencies. So this word cloud we are going to plot now with a similar assumption. So we have imported the word cloud and the stopwords. So this is how word cloud is actually defined. So we can define any background color. We can remove the stopwords, how many words you want to display in that word cloud, maximum font size, scale, etc. So if you do this, and if I plot this with the plotting terms as well, if I can just mention the subtitle, etc. So you could just see this is a word cloud generated on top of reviews basically. So this is a word cloud for a review column basically. So you could see the good, great are appearing more times. That's why the size of those words are becoming more bigger and bigger when compared to other words which are very small, such as instead, outfit, dressy. So these are the words which have occurred or less frequently occurred in our data set. So this is for the reviews. What if I pass uh, instead of reviews as a column, if I pass the review title, let's see what we'll get in the word cloud. You could just see the word cloud has generated the word title based on the review title. You can just see wonderful, good, disappointed. So just by the title, we can just say that particular review is a positive or negative, right? So even the word cloud says the same. So good is a word appear more frequently when compared to other words such as a review title, length, object, name, etc. So now that we have uh, built a word cloud to analyze the most frequent occurred words in a more pictorial or pleasing way for the reviews and the review title. What if we take each and every token or individual unigram from each and from the review, and if we plot a uh, word cloud, it will be the similar way. You can just see the same words are getting repeated. So you can just see great is the most repeated word, buy is the most repeated word, smell, review, etc. So these are all the most frequent words present in our dataset. So the word cloud actually improvised version of a bar plot basically. This is a bar plot, right? So this is a bar plot which indicated the frequency distribution. So word cloud is an improvised version of bar plot with a better pictorial representation for business basically. So a business person, if he comes and see that, okay, my current review data set actually have the words smell, buy, great, review, look, here, etc. So he will get a better understanding about what the data set or actually people talking about their products in a particular way. So we are, we are at the end of exploring the data set or exploratory data analysis. We have left with one task, that is identifying the genuine reviews. So what does genuine review means? A review which is actually provided by a buyer. What it indicates is whether the review given by the user is actually given by the user who actually made a purchase. So anybody can come and give a review for that particular product, right? Even without purchasing that product, I can give a review. So genuine review is one where the customer actually purchased the product and he has given the review. So we have a column called reviews.did purchase. So this particular column will help me to identify whether the review is actually genuine or not. So if you just see the count plot for reviews did purchase column, you can just see we don't have a sufficient data which explains whether the review is given by the customer who has made a purchase or not, because it has a null value with the highest count. But if you just consider true and false, you can just see false being the highest when compared to true. What does this mean? The reviewers which who are actually reviewing the product actually didn't make a purchase. They are just coming and reviewing the product without actually making the purchase. That's what our dataset says by this particular plot. If I go by the count here as well, the exact counts would be null values as 38,758, false as 28,474, and true value as 3,682. So shoppers who did purchase the product and provided the review is only 5%. That is, percentage of genuine review is only 5.4%. Rest of the thing is either null or is either a false value. So let's have another introspect of our data as well by plotting a correlation map. So what does correlation map will do? We try to list all the columns present in the x-axis and repeats the same column in the y-axis. We try to correlate or the dependency of one column with respect to another. So when I plot that using this uh, correlation heat map, you can just see this is how a correlation map looks like. So review ID is dependent on, uh, you can just see with the highest positive value 0.76 is year. So review ID is dependent on year, then it is dependent on some other aspects as well. So the orange ones, basically the heat maps you can see the highest value would be 1, that is highest correlation would be 1, because review ID with respect to review ID will be always 1. So this diagonal will always remains 1. But lesser than 1 values would be the most correlated values. You can just see minute and second are correlated. Then month, or you can see the review ID is dependent on year, more correlated. So this is for a heat map for a reviews all the columns in our data set versus all the columns in our data set. Now we will see another aspects of our data, that is most bought product. So how do you know this? I have taken this review did purchase equals to true, and I have plotted the count. Basically I have made a count for this review purchase. If a given review, I will check the column whether it is a purchase made or not. So then based on that you can just see this particular product has 477 purchases when compared to other products such as black gold, 90th birthday balloon, etc., which have only one purchase. So the most purchased product in our data set is the food saver, uh, the Pantene air spray, and home chili, no beans, etc. So these are all the top purchased product in our dataset. So if I make a plot for this, bar plot for this, you can just see 5,000 products, almost 500 products uh, are made, or purchases are made for this particular product when compared to Pantene, then compared to Hormel, chili, etc. So this will yield me the most purchases made in our dataset. Then we have a final interrogation, that is most purchases or most product purchase made which actually falls under the category of rating 5. So here we haven't taken the influence of rating. We have just counted the number of purchases for each and every product. Now what we will try to see is a compare the product purchase with the ratings. So now I have made a purchase, and what are all the count, how many times that purchase have been rated 5. So the genuine purchase, that is this is the product which I can see it has a most purchases. So now I am trying to see for this particular product how many reviews are actually falling under the rating scale of 5. So you could just see these are all the ratings which actually speak or actually rated 5 for this one particular product, that is the very top most purchased product. If you just keep on changing the product name and keep the rest of the code common, you can see the number of rating ID or a rating ID which actually falls under the category of rating 5. So if I do the opposite of this, or for the same product category, if I see the rating which has rated very less, that is rating value equals to 1, you can see the least rated values for the same particular product. So by this, we have concluded the exploratory data analysis. So we have got more and more insights about the data from the beginning of the session until now. So we have better understanding of our data when compared to initial step or initial steps of the data understanding. So in the next session, what we are going to do, we are going to build a machine learning model and a deep learning model based on this particular data set. So by this data analysis, what we come to conclusion, what we can conclude that rating, product rating is what the target column for our sentiment analysis, and all the other columns such as category, manufacturer, year of purchase, etc. are the influencing or the dependent parameters for this particular rating. So based on these assumptions or based on these parameters which we defined or analyzed based on the exploratory data analysis, we are going to build a machine learning model also as well as a deep learning model to build a sentiment analysis, and we'll try to explore the sentiment of a given review.